Hello, and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Ethan Mueller.
Hello, everyone, and welcome back to another episode of KYZEN's Tech to Tech. Today, we're going to be discussing defluxing with co-solvent process. And co-solvent is an industry term for a specific solvent cleaning application. And so we'll be discussing some of the reasons we might look to that application for cleaning. When we're talking about solvent cleaning, it's typically thought of as open-top vapor degreasing. This is generally what you'll come across out in the field. And this is very similar to co-solvent, but there are some differences. So I'll go over how vapor degreasing works, and that will build kind of on how the co-solvent process works. So in vapor degreasing, you're using one solvent. I'll refer to this as mono-solvent throughout the presentation. And so you're using one solvent throughout the whole system. So you have solvent in your boil sump, you have solvent in your rinse sump. Those two solvents are the same. We're boiling this boil sump to generate a vapor. And this is typically where we're cleaning our parts, is in this vapor zone. So that vapor comes up, it condenses on these coils, it's turned back into a liquid, it collects in this trowel, goes through water separator, comes back into the rinse sump as a nice clean solvent. So again, our parts come down into here. We typically suspend right above the boil sump. And what we're doing is that vapor is condensing on our part that, came from the room. So it's at ambient temperature, and that vapor can actually condense on that part and drip back down. And we're doing this over the boil sump. So any soils or residues that are on our parts are being collected in the boil sump. Then from there, we'll typically move our parts over and we can immerse directly into the rinse sump because we're considering this to be clean solvent. And so we're introducing our parts to a nice clean sump here. Oftentimes, these units will be equipped with ultrasonics, so we get some more cleaning action there. The co-solvent process is very similar to that vapor degreasing process. All the things that we described are part of the co-solvent process. You're using the same equipment, same kind of process. The only difference is that in this boil sump, we are adding a solvating agent. And so instead of having a mono-solvent system, we have a base solvent and we have our solvating agent. And that solvating agent lives right here in the boil sump. It's not over here in the rinse sump. And it's typically a high boiling point liquid. So we have a solution down here of our base solvent and our solvating agent. And we are, just like as in the typical vapor degreaser, we're boiling this solvent, but that solvating agent makes up a very small fraction of the vapor. So it's mostly in this vapor zone up here. It's mostly that base solvent. And so where in, a lot of recipes will call for just suspending your part right here above the boil sump, in the co-solvent process, we actually immerse our part in the boil sump to get that solvating agent to do some of the cleaning that we're after. And then as a traditional vapor degreasing process will come out, and we'll go into the rinse sump, and then maybe we'll hang out in the vapor zone for a little bit to dry, go in the coils to dry, and then our part comes out nice, clean, and dry. When we're working on these projects with customers, this dual solvent technology, which is another industry term for a specific solvent cleaning operation, this dual solvent term will come up. Co-solvent, dual solvent. When you're just talking, again, these things get conflated and confused. And so it's best to just make note of it and discuss the differences. Dual solvent is you actually have a solvating agent upstream of a vapor degreaser of a mono-solvent process. And so typically we're using a solvating agent because it's good to clean what we're trying to remove, and our parts go in, we clean them up really nice, and then they come out but that solvating agent, again, typically a high boiling point solvent, is lousy to flash away and dry away. And so now we go downstream into a vapor degreaser, and we'll actually rinse, likely further clean our parts, but really rinse away that solvating agent and whatever residues it had in solution. And then that solvent readily flashes away from our part. And so we have a nice, clean, dry part coming out of the system. Typically, these setups, they don't really look like this. It's usually a satellite tank, just a heated, turbulated tank upstream of a very standard vapor degreaser mono-solvent process. So when we're looking at a cleaning project, why would we look to solvent? Solvent has some environmental drawbacks. It tends to be expensive, so on, so forth. But really, solvent is a great cleaner. So when solvent and aqueous can both be utilized for a cleaning operation, solvent tends to clean better and it tends to clean faster. Solvent has a really low surface tension. And so where water might, bridge a gap and not penetrate into that feature of our part, solvent typically does a pretty good job to drop in there. It does a better job than water, I should say, to get in those parts. And then solvent also dries really good. So it's cleaning good. It's getting into these features. It's cleaning them out, and then it's drying away. So it's going in, it's coming back out, and it's drying away from our part. In addition, solvent has low residue, right? When we take solvent off a shelf fresh, it's 0.02 some decimal NVR free. So we're not really introducing new residues to our part. DI water is also very low residue, but it's not typically a great cleaner. And so when we add a chemical additive to our water to make it a better cleaner, as a rule, you're adding NVR. And so you're introducing a new residue to your part, which can be problematic in some scenarios. And so again, solvent kind of answers that question when you can't introduce water or residue to your part. Solvent in a mono solvent operation, you're running it neat, right? You're running it at 100%. And so that really simplifies the process and makes it easier to monitor and maintain. And because we're running it neat, we can recycle it, we can distill it, and we can clean dirty solvent and return it back to our process for reuse, which has a cost savings. There's an environmental savings there. There's really a lot of advantages to solvent being recyclable. Why would we opt for a co-solvent process, right? So we've determined why we would use solvent. So we're looking at solvent. Now, why are we taking that step further to co-solvent? And really, the reason is because typically, things in electronics, things that solvent can clean aren't always what we're trying to clean. And so we add that solvating agent into the mix, and it's really good at cleaning ionics, right? So to kind of talk to the slide, we don't want water in our process. We have low standoff components. We want to be able to clean and dry our parts. Or we want a single piece of equipment. So those might all be reasons that we're looking to co-solvent. But really, the main reason is that we're probably trying to remove flux or ionics, and solvent typically just really does not do a good job to clean those flux residues away. And so, we want all those other features of a mono-solvent cleaning process, but mono-solvent just won't clean what we're trying to clean. And so we add that co-solvent, that solvating agent into our boil sump to make a better cleaning solution. When it comes to best practices for co-solvent, again, that standard vapor degreasing best practices, right? So all those things hold true to the co-solvent process. And we have a tech-to-tech on that. So I'd encourage you to go back and check that out. But more important. It's important in vapor degreasing as well, but I think you'll find it even more so important in the co-solvent process is maintaining a clean water separator. Sometimes these solvating agents have more of a tendency to pull water into the system, and so we want to do our best to get that water back out of the system. Something that we don't need to do in a mono-solvent process, we do need to do in a co-solvent process. We need to monitor the concentration of that solvating agent in our degreaser. So we need to come up with some sort of way to make sure that if we want to be at a 30-70 ratio of solvating agent to solvent, we want to come up with a way to monitor that and maintain that process. It's really important in co-solvent to maintain your liquid levels, because again, that rinse tank, that rinse sump is always cascading over into the boil sump. And if we allow that rinse sump to get low and we're immersing in that boil sump, now when we bring our parts over to the rinse sump, we're introducing residue, we're introducing a wet part into the rinse sump. And so that solvating agent residue that's still on the part is now going into the rinse tank, and it's not cascading back over into the boil sump. So it's basically accumulating there, and we're soiling our rinse sump, which in a cleaning process is a problem and something that we really don't want to do. So again, maintaining liquid levels so that your rinse sump can constantly overflow into the boil sump is going to be a good practice. Honorable mention, inline distillation. Again, we can recycle solvent, and there's a lot of advantages to that. When we do a distillation on a co-solvent process, it's a little bit nuanced, and so I have a slide on that we'll just kind of go over that in a little bit of detail. So when we're monitoring the process, right, we need to come up with a way to monitor our process for that solvating agent. Typically, how we do it at KYZEN is we have a temperature curve. So we understand what the boiling point of the liquid in the boil sump is going to be. And at different ratios, that boiling point changes. So we can monitor the boiling point to know what our solvating agent concentration is at. NVR, this isn't really, you could use this a little bit to maybe monitor your solvating agent, but it's more used for bath loading, right? And so that solvating agent it lives in the boil sump. That's the only place it goes. More parts go in, the more soil you have in that material. And so as that builds, that NVR climbs, and we can monitor that NVR and come up with a time when we need to start over, dump, clean out our machine, clean out our sumps, and recharge with fresh. And then refractive index, this is a way that we can monitor water content. Again, some of these solvating agents have a tendency to take on some water, where solvent typically kicks water out. And so we'll use refractive index to monitor that. So temperature curve is telling us about our concentration. NVR is telling us about our soil levels, and refractive index is helping us understand the water in our process, in our machine. So there's always health and safety considerations when it comes to solvent. A lot of solvents have a personal exposure limit, typically regulated by OSHA. And so when we're looking at a solvent process or a co-solvent process or a dual solvent process, a liquid that puts off a vapor, we want to know what our personal exposure limits are, and we want to make sure that we're building our equipment and having our rooms set up to accommodate that and to achieve that part per million, be lower than that part per million. Flammability. This is really important when it comes to solvent, because this is probably one of the more immediate dangers pertaining to solvent. And there's a lot of solvents out there that are flammable. And so when they start on fire, they continue to burn, or they're explosive. And again, we're heating this liquid and we're turning it into a vapor. And so that's when combustible or flammable liquids are most flammable. is in their vapor phase. And so, again, a question we want to ask ourselves, there are non-flammable, non-combustible solvents out there in the marketplace. So just be aware of that, cognizant of that. VOC, hazardous air pollutant, these are local concerns. VOC tends to be problematic for people with asthma and for, your local ecosystem. Hazardous air pollutants is, are we putting some sort of carcinogenic material out there into the atmosphere? And so again, solvents are VOCs. Solvents can be hazardous air pollutants, so something we want to be aware of. Global warmer, ozone depleting. We're not going to be having any ozone depleting. A lot of solvents are ozone depleting, but they're phased out. They're banned by the government, so we can't even use those. So hopefully we don't get our hands on those. But a lot of solvents are global warmer, right? And as we look to our corporate initiatives and our government, our regulating agencies, they're looking to phase these things down. And so again, something that we want to be cognizant of is avoiding global warmers. And the new buzzword is PFAS. So we've all heard of PFAS. PFAS is a forever chemical. Different regulating bodies have different definitions for PFAS. And so again, we want to be, when we're looking to implement a new process, we want to be aware of all of these things. And these two, global warming and PFAS, are kind of, those things are shaking out as we speak. Global warmers, just for reference, HFEs are a common degreasing agent. It's a PFAS by definition, but it's also a global warmer. I'm sorry, I said HFE. I meant HFC. HFE is not a global warmer. HFE is not a global warmer. HFC is a global warmer. And so, as you're implementing a new process, you would be doing yourself a disservice to validate a brand new cleaning process with an HFC material, because the government's actively phasing global warmers down, and they're putting language out there into the market. They're conveying to the public that they're going to be doing things to regulate PFAS. And so HFC, again, it's a PFAS, and it's a global warmer. So, it'd probably be in our best interest to look for other solvent materials. So in conclusion, why would we look to solvent, or even more so look to co-solvent for our cleaning process? Co-solvent is a singular piece of equipment, so we don't need to invest in two pieces of equipment or have, we have a small space available for our cleaning process. We can do it all in one tight little one machine with a small footprint. And then, the special case uses of, I can't have water, or my parts, I can use water, but my parts are really complex. I have tight pitches and low standoffs on my electronics, and water just doesn't seem to really get under there and do a good job to clean. And then, maybe we just have really tough soils that the solvating agent has proven to be very effective at removing. And so you kind of look at all these things, and it makes the case for, hey, co-solvent might be a good process for what I'm trying to clean. Some frequently asked questions. Should I use co-solvent for maintenance cleaning, or maybe general degreasing? And I would say no. You don't. If you have one cleaning process and you're okay with doing your maintenance cleaning in the same equipment that you're doing your production cleaning, then that's fine. I'm sure it would clean good. But for standard degreasing, you don't need to have the co-solvent. Typically, mono-solvent process, an open-top vapor degreaser, will do a really good job. And there's other technology out there too, such as vacuum degreasing and whatnot, to do some general degreasing. When should I use solvent instead of aqueous? We answered some of these kind of throughout the presentation. If you can't have water, I've seen that a lot, where people don't want to immerse their part in water or subject their part to water. And really the only way to clean with water is to apply, to either immerse your part in water or spray water onto your part. And so that vapor process, that vapor cleaning process, you're skipping the rinse immersion, but that process can give you kind of a water-free immersion-free type process, and it still cleans pretty good. So if you can clean in that type of scenario, that might be a situation where you want to look at solvent. Can water-soluble flux be cleaned in co-solvent? This is a really good question because I would almost always, if we're starting out square one, I don't know any details, you haven't told me that you can't use water yet, I would absolutely push you in a water cleaning direction, right? We want to clean in aqueous. We want to clean water soluble in aqueous. Solvent, a mono-solvent is really lousy at cleaning. I mean, it's lousy at cleaning most flux other than rosin flux. But it's really lousy at cleaning water soluble flux. But that solvating agent, it kind of brings a little bit more to the table. And so you'd probably be able to clean your water soluble fluxes in the co-solvent process. Again, if you're maybe you're doing some no clean stuff and you're cleaning all those in your co-solvent and you have some water soluble work that you do, I think you'd be fine. I think you'd get a good cleaning result out of that. When do I need to change my solution, my solvating solution? And this is something that we need to do some work on, right? For your project specifically, we have to look at process, your work, what are your requirements, so on and so forth. And typically how we do this is we collect data on the bath, that NVR data, maybe some other data as well, like rinsability and whatnot. And we try to marry it to some sort of quality data. If you're doing IC testing or ROSE testing or whatever kind of quality checks you're doing, we want to marry those two things together. And that's going to give us a really nice picture of when is my bath optimally used and I should change it out and start fresh. And, we want to do those things because we want to have a cost-effective process, but we also want to have a consistently clean part, right? And so that's a balancing act. We need to do a little bit of legwork, but we can definitely get there. So, we're always happy to help with that type of thing because some of this does take some lab analysis. So with that, I will turn it back over to William.
Thanks, Ethan. Thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.